Hello everyone, welcome. Thank you for joining today. Before we get started, I'd just like to go over the notifications and sounds. So if you'd all just like to go to your notification settings, if you go to the cog symbol or your settings, if you're on mobile, it might be in your session menu, but if you're on a computer or a desktop, it should be in your bottom right hand corner, and just untick all the notification settings underneath there. And that includes you as well, Ali, just to make sure everyone doesn't receive any sounds or pop-ups during the session, which can be disturbing. So my name is Riley, and I'll be hosting this webinar for you all today. The technical topic for today's webinar is on industrial automation, Industry 4 and smart factories. Now this is being presented by Dr. Ali Mazougi, who is a lecturer and a unit coordinator with us at EIT. Just some common questions. So a copy of the slides and the video recording will be sent to everyone in this session, as well as everyone else that's registered for this webinar via email. And because this webinar is a little bit earlier than what we would usually do, I'll send that out to you all this afternoon. We also provide a free digital certificate of attendance for these sessions. So I will provide a link and a QR code at the end of the webinar, which links to a short form that you must fill out if you would like to receive one. So just briefly about EIT. So we are an engineering specialist education provider. We offer a range of courses only in engineering, ranging from professional certificates, which are our short courses, to diplomas and advanced diplomas, undergraduate and graduate certificates, bachelor's and master's degrees, and a Doctor of Engineering. And we have industry-oriented programs, so all of our courses are regularly updated to stay relevant with the industry and make sure that our students have the best graduate outcomes possible. Our vocational programs and higher education degrees are registered and accredited by the Australian government. However, we do have courses that are internationally recognised under one of the three international engineering accords, so the Sydney, the Dublin, and the Washington Accord. We have industry experienced lecturers, so not only those who are involved in academia, but those who have real world industry experience that they can apply to their teaching. We have a unique delivery model, which includes live and interactive webinars, such as this one that you're in today. However, we have small class sizes. So as this is a free webinar, we have about 160 people in the session so far. In our courses, we have small class sizes, so we promote interaction a lot more with your peers and your lecturers. We have I mentioned our lecturers, and they come from all over the world. Our dedicated learning support, we have learning support officers that that help every student from when they start the course to when they graduate. We also have state-of-the-art technologies such as hands-on workshops, remote laboratories, and simulation software. I'll now hand over to Dr. Ali, who I mentioned is one of our lecturers and unit coordinators. He'll now briefly introduce himself and present this technical webinar for you today. Thanks, Ali.
Thank you so much, Riley. Hello, everyone. As Riley mentioned, I'm Ali Marzougi, and I'm working with EIT as a lecturer and unit coordinator with a background of electrical engineering, mainly instrumentation, control, and robotics. So I'm from oil and gas industry mostly, and then worked in different industries in different positions of engineering in turnkey projects, EPC contracts, and yeah, now I'm very happy to present this brief introduction about industrial automation to you guys, and hope we all enjoy of this session. Just a quick note, unfortunately, because the number of attendees are high, which is very good, I'm not able to answer you during the presentation because it's a little bit distract me. So we have Q&A, I think, at the end of the presentation session, so you can ask your question at that time. But in between, I have some polling, so I ask some questions. They are normally yes or no questions. Then you can answer these questions, which is very good for all of us. So today we are talking about industrial automation. So we start with industrial automation and introduction, and then go step by step to reach the smart factories, which is the future trends of the factories around the world. So as I've received some message about audio, can you please confirm if you all have problem of audio, or you can hear me and this is working fine? Thank you so much. All right, I'm sorry for that. Yeah. Okay, and then we have Q&A. You can ask your question if there is any question. So what is the industrial automation? Industrial automation actually is defined as combination of logic commands and mechanized equipment. So when we are talking about mechanized equipment, it doesn't mean that just mechanical equipment. So it should be mechanized. It includes all mechanized equipment like switches, even like non-contacting switches, like SCRs, like thyristors, high frequency fast switching devices. While they are combining with logic programming commands, our machines can make decision automatically, can do the task automatically without interaction of human being or with collaboration with human being. So we can say that automation replaces the decision making and manual command response activities of human. So there are some concepts in industrial automation. When we are talking about industrial automation, the first thing comes to our mind is analog and digital. So normally what do we have around us? Like the signals to be measured, which is the main part of every factories or manufacturing or process, all comes in analog forms and they should be digitized. So analog and digital is the main concept. Then definitely to transfer these data, to receive these data, we need also input-output concept. Then this input-output concept based on what numbering system. So numbering system is another important concept. It could be binary, it could be decimal, it could be hexadecimal, ASCII codes, bytes, or any other type of a numbering system. So we need electrical power. So we need voltages, currents, frequency, and all these concepts. Or it could be hydraulic and pneumatic. Another concept of automation, industrial automation, is the process itself. So is this a synchronous process? Is this a asynchronous process? Is this continuous process or discrete process or some other terms? And then safety, which is very important and should be considered in any process plan, any factories, and everywhere which we are working with the machines. For example, hazard analysis, which is very important in industrial automation, and controllers. Without controllers, automation will be deleted. So control is the most important and the main part of industrial automation. So either we are using DCS, either we are using PLCs, or embedded microprocessors and microcontrollers, and the interfaces and the sensors for gathering data, for collecting data, for analyzing data, and for transmitting and transferring data, and motors and actuators. At the end of the spectrum, what do we want to do? And what is the main purpose of industrial automation is moving motors and actuators based on intelligent decision and based on type of controls that we are applying for our process and the system. All right. So we back to the history of automation. There are different claims, but the most famous one is creating the word automation by Delmar Harder, who was the vice president of manufacturing section in Ford Motor Company in the United States at 1946. In some resources, they said 1947. So the first department in Ford has been created by under the name of automation department. So this automation department was responsible for creating and automizing electromechanical systems. They have electromechanical control devices. So they use these electromechanical control devices and the very early manufactured logics, such as relays, timers, interlock switches, and position sensors. And then using electromechanical devices, control devices, and some simple commands, simple logic sequences, they could turn on and off motors and actuators. So they automized fully manual manufacturing systems for the first time. Maybe it's not for the first time, but the word automation is developed for the first time at that company. So what is the advantages of automation? What industrial automation, why we are going through industrial automation, to apply industrial automation with all our system? Definitely the advantages of industrial automation is not countable. So there are lots of advantages, but few of them, or very few of them, is listed here. For example, for heavy load, carrying heavy loads, so machines works better than the human body. And if the machine can make decision on their own autonomously, so it increases the precision, it enhances the productivity, and save the time. Or while we are talking about the hazardous or extreme temperatures area, some area which is toxic with any other toxic materials, like some areas which is at the danger of radioactive. So all of them could be done by automatic machines, faster and safer than using human being in there. So we can save on labor cost, and we can increase the production quality, and it can lead us to faster production. And machines, automatic machines, could be used for quality verification, so quality check purposes. Actually, for quality check purposes, Q&A, while we are using machines, maybe you say that, all right, it has initial cost, which is high, or because this machine should check quality of a certain product, so we have to design and manufacture special machine for just specific purposes. But yes, initially maybe it has some cost, but at the end of the spectrum, when you design a certain machine, when you train the machine for special purposes, for QA purposes, then the result will be more precise, will be more accurate, and you get benefit of less failure in your production. Definitely, when we are talking about the advantages, we have to talk about disadvantages as well. There should be some disadvantages that we need to work on them. For example, initial cost is one of the disadvantages that we talked about previously, so it has high initial cost. For example, in some special skills, machines are not working as good as human is working, because we can say that human is the most advanced autonomous machine by far. So we can do delicate and sensitive works. If you don't believe that, look at your fingers. They are like a miracle. So you can do many things with your fingers. Very delicate jobs and sensitive jobs. Also, some machines has been designed, produced for doing some stuff. For example, in health, you can see that lots of robots, which is serving in health industry for very sensitive operation. They go through the body, they do some very sensitive and delicate jobs, but they have, so far, they are under control of human body. So this is another disadvantages. This could be, and these disadvantages will be smoothened during the time. So we are working on that. We are creating some platforms. We are using machine learning to teach the machines, to teach the robots to learn from their mistakes and to learn how to learn from their environment. And another thing is the cost for the research and development. So we can't predict the cost for the research and development. Sometimes the research and development will cost a lot, but at the end of the spectrum, you can't get the desired output of that. But it happens a little bit because What you can see, all the developments in the industrial automation and the robotics all comes from working academics and industry hands to hand. Without any of them, another one is impossible. And then we are talking about the evolution of industrial automation. So before we are going to talk about the evolution of industrial automation, I want to tell you something. What we are going to do in developing the industry, especially developing the computer science, programming, and electronic and electrical stuff, all together industrial automation. What we are going to do, what our scientists are going to do, what our engineers and designers and technicians and everyone, we are going to find the patterns. Patterns are very important for learning, for increasing and enhancing the productivity. Pattern should be recognized and followed. So there is a quote from Alfred North Whitehead. So he said, art is imposing a pattern on experience, and our aesthetic enjoyment is in the recognition of the pattern. So this is our most and the most important capability, that we can recognize and follow the patterns. And we want to teach this to the machines as well. So we are go back to evolution of industrial automation. Industrial automation started from steam era. So we had agriculture era, which transferred to steam era. In steam era, we had mechanical manufacturing. So we call it as Industry 1. And then it's been developed to tends to mass production, while we had electric powered machines. So getting advantage of electric powered machines, we had mass production, and then we call it as Industry 2. And then after that, we move forward to Industry 3, when IT was created. All right. So in this case, robots started to be developed and improved for certain jobs. They programmed to follow specific patterns. For example, in automotive industry, you can see lots of robots. In packing or placing, you can find lots of robots. In manufacturing industry, and recently in building industry. This is a massive evolution in building industry. What you can see, 3D printers. They can build a building in 3 days. Or another example of 3D printers is creating any other objects using welding principle. So this is the era of Industry 4. So we are on the overlap of Industry 3 and Industry 4, but mostly we are moving to Industry 4. Industry 4 is the era of cyber physical systems to get advantage of machine learning and artificial intelligence, which makes our machine to be able to autonomously think, make decision, and act. Also, they can share their information. So machine learning and artificial intelligence are the main part of cyber physical systems, are the main part of these technology. So they are working as a brain of our equipment to help them to be autonomous in the future. For example, in AI, what do you have? You have, while you are developing AI, you train AI, you have training phase, you have testing phase, and then you have error minimizing phase or using backpropagation method. So what is this method? This is a kind of method that human is doing in daily life. So what you're doing, since you are a kid, you start being trained by your parents, by your environment, go to the school, education, everywhere. And then while you're coming back to the real world, you have to test this training. Definitely everyone of us make mistakes. And then we learn from these mistakes. And we try to minimize these mistakes. So that's exactly what artificial intelligence and in some advanced model machine learning is doing now with our robots and with our software robots tools. Learning from the mistakes, training from the environment. And then another one is another development so far is Industry 5, which is based on personalization, which we are not talking about that in this session. We are stop over here, Industry 4. But Industry 5, in summary, is the cooperation between, is a sustainable cooperation between human and the robots. While we have autonomous robots, they can make decisions. We have productive collaboration between the robots and the human in our future industry. So, industrial automation could be developed and could be improved by industrial internet. This is another step which we talked about that to reach the smart factories. Now, what I want to do, I want to tell you about 5 hardware and software sets work shoulder to shoulder to create a better visibility and insight into a company or into an organization or whatever. So they are includes machine sensors, middlewares, software, backend cloud computing and storage systems. Software, we all know about the softwares. Then we have middleware. So a middleware lies between the operating system and the application. All right. So for example, what do we have? We have application programming interface, or we call it as API. This is some kind of example of middleware. Or in your system, you have coding. This is another example of middleware. or you have event processing or integration. Then we jump to software, which is clearly obvious for every one of us, and then we are going to cloud computing. Cloud computing is an environment in the internet which includes servers, storage, our database, and networking, and software, and all analytics. And we have a storage system which could be included in cloud. It could be cloud-based. So they are all, it creates industrial Internet of Things. So we can summarize the industrial automation includes important terms which we can name them as Industrial Internet of Things or IIoT, Industry 4, Smart Manufacturing, and all of them lead us to smart factories. All right. Okay, I want to make a pool, and then you can ask this question. This is a yes/no question, please. I just typed the question. So there is a question about smart sensors. Smart sensors are normal sensors, but more precise. This is a yes/no question. I'm not quite sure if, oh yes, that's good. So we have more yes than no. That's a good question. That's a very challenging question. That's very good. I'm waiting for a few more seconds. Yeah, that's good. That's good. This is a very happy question. All right. All right, so what I can see is a number of attendees who believe that this sentence is a correct sentence is more than double the number of people who disagree with that. Okay, so we have 86 yes and 13 no's. Another question that I want to okay, so another question which I want you please quickly answer is about big data is just about the volume of data. Okay, so I start this question. Is this correct or wrong? That's good. So we have All right. Just a few more seconds and then we can stop this poll. All right. That's good because of the time. I stop this poll now and then thank you so much for your kind response and interacting. All right, so the purpose of these two questions was we want to check if the smart sensors are normal sensors but more precise, and we want to see if big data is just about the volume of data or there is something else that we have to consider. All right, for the first question, unfortunately, more than half of you said smart sensors are normal sensors but more precise, which is not a correct answer. But for the second one, fortunately, more than half of you believe that big data is not just about the volume. So why we did ask these questions? Because these two are the key technologies of industrial Internet of Things. So we have smart sensors, which are advanced technologies, and we have big data, which gathered, which collect, processed, and transfer by smart sensors. So we have two different terms, smart sensors, intelligent sensors. Some researchers and some technicals believe that these smart sensors and intelligent sensors are totally different because they think that smart sensors just collect data, take measurement, transmit data to the cloud computing and analysis for further analysis. But intelligent sensors do some signal processing techniques, data fusion, intelligent algorithm, artificial intelligence, machine learning, and so on. So what I can see is combination of both of them, smart or intelligent, doesn't matter. So smart sensors, this is just disagreement on words, I believe. And we can say that smart sensors are more than a normal sensors with high precision. Smart sensors is kind of sensors who can collect data, analyze data, process data, and then transfer data through Wi-Fi or some other networking protocols to the cloud for monitoring purposes. And smart sensors of the future are the sensors who have brain and can process data and make decisions. So smart sensors are not just normal sensors with high precision. Smart sensors can make, maybe not all of them now, but in the future can make decisions based on data processing, based on data analysis. They are using machine learning and artificial intelligence to process data and to train themselves based on the environment, the area they are located, and the condition which could be changed time to time. Another term that most of you agreed that it's not just about the volume of data, is big data, which is another key technology in the industrial Internet of Things. This is about volume, size of data. This says, all right, big data. But it's about the velocity of data streaming analysis, variety of data. Where does these data come from? Either you have PDF files, a huge number of PDF files, or you receive lots of emails and PDF files, you receive voices, you receive videos, text, and lots of other information as data, as raw data. So variety of them. Variability of data. Veracity of data, if data is suitable or not, and the value of data. If data has value, if this scenario has value to be further analysis, to spend time to be cleaned and analyzed and do other purposes, other processes. So all of them defined as in categories of big data. So big data should have all these features. All right. So I think that question was a good question for you to practice something and remember something important. So there are some examples of smart sensors. What you can see is DUT GSM 11 sensors, and in these type of sensors, you can measure the level and you can see the amount of fuel left in the vehicle. Definitely, there is some processors or some simple processors in the sensors which has capability of calculation based on the program, so it can show you the amount of fuel which is left in the vehicle, and they can calculate how many kilometers you can approximately drive with your car, for example. This is a simple example, and then they can transfer data through GPS or GSM. So it has capability of transferring data to the cloud for further processing and monitoring. There are different types of smart sensors, like smart tracking sensors, machinery health sensors. For example, in case of the machinery health sensors, you have ECGs. So like electrocardiograph, which is wearable sensors. Patient could wear these sensors and live their life, normal life, and then send data to the hospital without being directly into the hospital, and then being monitored for a month or more or less, whenever is required, and then how long is required, and then they can make on their health decision by checking the heart rate in different situations, the heart rhythm, and so on. So they are smart sensors. Another type of smart sensors, which is very famous, and you can find it in lots of manufacturing industries, lots of plants, oil and gas industry, is a radio frequency identification sensors, or we call it as RFID tags, RFID tags. So you can find it in the shops as well. Some shops, rather than having barcode, they have RFID tags. So this RFID tag works based on radio waves. So we are talking about that in a case study at the end of this session, which is very interesting. And then we are going to talk about cyber physical system, which we mentioned previously as a part of industrial internet in Industry 4. So cyber physical system provides an opportunity for a digital world to be merged with analog world. It happens through interaction of process management and feedback control, and then it results in IIoT, big data, services in Industry 4. So what you can see, for example, you have a system, a robotic system in your assembly line, for example, or in production line, a welding robot, say. So what do you need in this? What do you have available? You have either 4 to 20 milliamp signals, which should be, for example, transferred by using RS-232 protocol serial. And then it should be digitized using A to D. So this is normal. We are using this in our industry 3 as well. This is not something new. But beyond that, you have digitized signals, which has to be transferred to cloud, which has to be analyzed by some smart sensors, which has to be transferred from cloud to either storage or real-time monitoring purposes, and so on. So this is type of cyber physical system works, merging analog and digital. Or for example, I can give you another example. For example, in oil and gas industry, what do you have is a sensor. So what do you have is, for example, sensor here, and then in drilling purposes for oil, for example. All right. So you have sensor, you have a drilling control, and you have process control. The process should be controlled as well. All right. So you have a process control. So in case of transferring data, what do you have? You have high speed data bus, and then data should be analytics. So you have analytics here. Data should be analyzed. And you have data storage here. It could be your first storage. All right. So from this section, you use wireless network to transfer data to another section, another storage, say, this is storage, or for preventive maintenance purposes. For preventive maintenance purposes, or for processing, process planners through a control bus, or we call it as control data bus. All right. So they are all called as cyber physical. Through this industry 4, definitely preventive maintenance is not a new term. So we are doing preventive maintenance since many years ago. At least as I remember, when I was at 2000 in oil and gas industry, we had preventive maintenance using Ethernet. But nowadays, Industry 4 helps us to have more accurate and real-time preventive maintenance for all the machines with less cost. So you have smart sensors. Smart sensors collect data, analyze data, and send processed data to your system through Wi-Fi. So you have more accurate preventive maintenance in different industries. And it works in different industries as well. So they were just some examples of these kind of cyber physical systems. Now we are reaching almost the last step, which is Industry 4. We talked about industrial automation, moved forward, step by step, up to reaching this step, which is Industry 4. And we can define Industry 4 based on all we talked about previously as an umbrella which covers new technological trends. And these new technological trends all work hands to hands to make industry smarter, with the capability of autonomous decision making for the machines, and all is in the benefit of the human and the world. For example, the most important thing that we are talking about in Industry 5 and some in Industry 4 as well, but mostly in Industry 5, is sustainability. So they are working together to get benefit for not just the human, but for the whole world. What is the vision of Industry 4? The vision of Industry 4, in summary, is industrial business will build a global network to communicate their machinery, factories, warehousing facilities, and all other facilities that they have as a cyber physical system. So we have to add machine learning in here because machine learning also is very important part of Industry 4. All right. Now I have another poll for you. So for the next slide, the question is, Industry 4 is a centralized concept. So this is a question. Please tell me if you agree with that or not. So we have more yes than no. Which is good again. Go ahead, please. Answer as much as you can, please. That's very good. That's very productive. Okay, that's good. So we have 98 yes, 45 no. Okay, I'm happy because I think this webinar is useful for all of us. So 97 of you guys believe that Industry 4 is a centralized concept, and about 40 something believe that Industry 4 is not a centralized concept. It means that Industry 4 is a decentralized concept. And I have to say that Industry 4 is a decentralized concept. One of the purpose of Industry 4 is to be decentralized. What is the meaning of decentralized, or decentralization when we are talking about Industry 4, which is decentralized? I'm going through each of them and explain each of them to see the design principle of Industry 4. So Industry 4 should be interoperability. All these 7 concepts, all these 7 principles mainly used in smart factories as well. So this is the design principle of smart factories as well. So Industry 4 should be interoperability. What does it mean by interoperability? It means that it should have the capability of, the components of Industry 4 or smart factory should be capable to communicate, connect, and operate together. So the components should be able to operate together using industrial Internet of Things. So maybe you say, all right, give us an example. So for example, we can say that we have, imagine that in a factory you have assembly section and you have another section which is palletizing section or sorting section. So while we are saying Industry 4 or smart factory should be interoperability, it means that assembly section is not a separate section of design section or palletizing section or packing section. They are all work together, communicate together. They have cooperation, they have collaboration together. So it should be interoperability. Another term is virtualization. Industry 4 should be capable for capability of virtualization for simulation purposes. What does it mean by virtualization? It means that before you physically set up a smart factory or any other Industry 4 based plant, process plant or whatever, it should be able to virtualize. You have to be able to design virtually, get data, analyze data, and out of this outcome, you will find the errors, you will find the bugs, you will find the productivity, and you can enhance the quality and reduce the errors and save the time after you have a very accurate and very good virtual simulation. Another term which most of you didn't agree with that is decentralization. So what is the meaning of decentralization? Decentralization is working in many aspects in our life, as from robotics, navigation, which I worked in that area a lot, so I have some publications as well. And it goes over and over to Industry 4. What does it mean by decentralization? Even in social science, we are talking about decentralization now. So decentralization is the capability of making decision autonomously, but this decision making should not result in deviating from the path. So you have a path, you have a goal, your organization, your factory, your plant, your process plant have a specific goal, but each module, each setup, or each section in your system can make their own decision without deviating from the path, from the final goal. So they have to in line with the final goal. What about centralization? That most of you agree that is a centralized system. Centralization means the system that we are using more currently. So we have a central brain which controls everything. We want to get rid of this type of management system. This is not about the management, this is about all aspects of the managerial systems. So technically, robots could be able to make their own best decision based on the special situation that they are getting involved with. And any other machines, sensors, smart sensors, mobile robots, arm robots, everything. So we want to be decentralized, but not deviating from the path. Another one is real-time capability. So Industry 4 or smart factories should be able to collect data in real time, collect data of a production and process, getting feedback in real time, and monitoring purposes and control purposes in real time. Industry 4 should be service oriented. So we have lots of internal, external services which is provided by Industry 4, and therefore we have to use industry, Internet of Things, to make sure that these services deliver and control and monitor real time in the right time from any location, if it's remotely or any location. Then another term is modularity. So modularity means, this is very important as well. In case of the modularity, Industry 4 says every individual product line. So you have individual production line, every individual product line, not just production, all right, product lines can be replaced, can be improved, or can be expand, or any other variation. But without disruption to the other product line. All right. So replacement, improvement, expansion is doable in any product line, but it shouldn't have negative impact on the other product lines. We call it as modularity. It means that every product line should be modular. And definitely security, cyber security is the most important part of Industry 4. All right, so what do we have? We have building blocks of Industry 4. It includes big data and analytics, autonomous robots, virtualization simulation, horizontal and vertical system integration, industrial Internet of Things, cybersecurity, cloud, and cloud computing, additive manufacturing, and augmented reality or virtual reality for simulation purposes. Now we are going to smart factories. I'm sorry if it takes a little bit longer than it should be, but it will be finished soon. So we have a concept of smart manufacturing. Smart manufacturing, before we are going to smart manufacturing, we have to know the concept of lean manufacturing, which we are using currently in around the world. Most of the companies use lean manufacturing concept or lean manufacturing strategies in their factories. So I have another poll, if you agree. So in this poll, I want to ask if lean manufacturing means faster production, but more waste. Okay, lean manufacturing means faster production but more waste. Is this correct or not? Do you agree or disagree? That's good. So most of you disagree with that. Very good responses. So a bit more. And all right, so it's about to the end. Can we reach 100? A little bit more. And all right. So I'm about to stop this poll. Okay, so what do we have is good. We reach 100. I'm very happy now. All right, that's good. Over 100. All right, that's good. That's good. It's an amazing interaction. All right, that's very good. All right. Okay, I stopped the poll. Oh, that's good. Oh, it's been stopped. Okay, that's very good. All right, so we had 103 no, which was definitely correct. Absolutely correct. Lean manufacturing is not lean manufacturing doesn't mean faster but more waste. In lean manufacturing strategy, we have 8 wastes, including transport, inventory, motion, waiting, overproduction, overprocessing defects, and unutilized talent that should be reduced. This is the main purpose of lean manufacturing. Reducing waste. So, for example, in transport, we have waste of time. If we have unnecessary moving products and materials, for example, in inventory, if we have excess products and materials that aren't processed. So in motion, if we have waste of time and efforts, if we have unnecessary movement by people. So we have wasting time for extra waiting for the next process to come. If we have overproduction, so we have waste in cost, and if the product is over than demand, and then for overprocessing, if we are making more effort on producing higher quality than required, higher quality product than required, so we waste lots of money and time. And then for the defects, if our products has some failures, So we have waste, and if we have a talented personnel, we have talented and skilled and knowledge people in our organization, and we are not using their talent, we are wasting their time and our time and our money, definitely. So this is the definition of lean manufacturing strategy. What about the smart manufacturing? Smart manufacturing is the lean manufacturing strategy with the capability of merging analog to digital, analog world to digital world, which results in enhancing process and smoothing goods delivery, increasing the consistency of good delivery. This is the abstract definition of smart manufacturing. All right. So smart manufacturing is a lean manufacturing which takes advantage of the features of Industry 4, which we talked about so far, to improve the production in case of the quality and everything related to. All right. So that was about smart manufacturing, and we can summarize smart manufacturing as a manufacturing process where products are smart or intelligent, business processes smart. So by business processes smart means there is capability of parallel processing, real-time responses to process control. There is capability of collaboration between machine to machine and machine to people on production line using cyber physical systems. And then smart manufacturing has an optimized supply chain. What does it mean by optimized supply chain? It means that if we had before make to stock, so we fabricate the products in our factory, we are fabricating the product, all right? So we say make, and then this product will be stocked to be sold. So stock to sold, to be sold, all right? This is the current trend. This should be shifted to either make to order. We make the product if there is order. We don't make product to stock them and then sell them. If there is order, we make the product. Or we say configure to order. What does it mean by configure to order? It means that product are assembled and configured based on customers' requirement, and we have engineered to order. It means that products are designed, engineered, and manufactured based on customers' requirement. And another thing about smart manufacturing is the customers. Customers are most important. Customers' evaluation is everything in smart manufacturing, which can highlight the strength and weaknesses of our industry, of our factory, of manufacturing and everything, and then we can improve these later on. All right. So you can see this smart factory at the end, which could be summarized as a host of smart manufacturing. And everything that we talked about so far. So industrial internet, smart sensors, cyber physical system, cloud computing, decentralization, everything is hosted by smart factories. So you have lots of decentralized autonomous machines, robots, which are working real time with cooperative with smart and intelligent sensors, data transformation within the communication protocols, and real-time monitoring, virtualization for simulation and other purposes. So this is a smart factory and the purpose of smart factory. So there are some requirements for the smart factory because we are running out of time. We are just touching that. This is a research approach. So smart factories should be modulars in both modulars and decentralized in both control and machine tools. So we need a multi-skilled workforce. Definitely when we are working with the robots who are intelligent and they can make decisions, we need some skilled workforce to be able to collaborate with these machines or sensors or any smart equipment and devices in our system. So online database, real-time monitoring, standardized virtual modeling language, which is very important. So we have to have standard for everything. So cloud computing, smart products, and standard for communication protocols. And the system should be healable. So the machines, for example, the robots should be healable. They have to be able to heal themselves in some point. Definitely not totally, but in some special point. And then there should be collaborative behavior between the machine and robot and human. So an example of smart factory is a state-of-the-art factories that is already established by General Electrics as a brilliant factory. This factory uses industrial Internet of Things. And based on that, GE produced an app, which call it as Prophecy Plant Application, MES, or Prophecy Smart Factory. So what does it do? It enables lean manufacturing through on cloud or hybrid solution, collects data, analyze data, and find all the bugs and all the requirements of the factory, and then helps the other process or the other industries to have a more productive, in shortened time, and less errors in their system, which is pre-designed. So in this case, designers create virtual construction, as we mentioned previously. So get the feedback through data, applies to the app. And then if this is successful, then the smart system will be created, all right? And this is a case study that I told you about, a very small example of smart factory, a very small example of very small part of a smart factory. So in this case study, which is happened by Morata, the challenges was there were some boxes and they have to be counted, and data should be gathered from the boxes, including the weight or manufacturing serial number and everything. Previously, they used barcodes And definitely they had a barcode reader there. And the barcode reader, so if this is a barcode reader, the barcode reader should directly see the barcode on the boxes. So imagine that something happened and the boxes will be moved or change the orientation, something. So these barcode reader can't read the barcode, and they missed one box or some other products and the information, which is not good. So what they've done, they, as a solution engineer, they implemented some RFID tags, which works based on radio waves, radio frequencies, and then they stick these tags on the boxes or products with the RFID reader. It doesn't matter if the RFID reader can see the RFID tag or not. It's not required, as long as there is waves received to the RF reader from RFID tag, which is programmed. RFID reader can capture all data, including serial numbers, model numbers, manufacturing process, or any other information which is required and which is programmed by the RFID to the RFID tags to be captured. And then it's been sent by using Wi-Fi for monitoring purposes, or in the database, or in real-time view data for analyzing and some other further operation. Thank you so much, and that was the end of this presentation, webinar. Hope it was useful for you. Thank you for your patience, and I'm so sorry because it took a little bit longer than it should be. It's supposed to take for 50, 45 minutes, 15 minutes, but it took longer, and I apologize for that, but I hope it was useful for you. I hand it to Riley now.
Thanks, Ali. I appreciate it, and I think going from all the comments coming through, everyone really enjoyed it and found it really informative. So thank you. And before we wrap up the session, I would just like to highlight our industrial automation courses. So we have a range of industrial automation courses at EIT. As I said at the start of the session, we have from short courses to advanced diplomas to bachelor's to master's courses in this field of engineering. It's one of our 4 main fields of engineering at EIT, and you can see down the bottom there. I'll just highlight that. There's all these topics that you can learn about with us at EIT. So if you'd like to get any more information on that, I'd recommend you reach out to us or visit our website and have a look. And moving on, we also have a technical webinar in a few weeks' time on gaming technology to improve industrial digital twins. This one is not being presented by an EIT lecturer like we usually have. However, this one is being presented by another company in Perth, where EIT's head office is based, by Sentient Computing. But it should be a very interesting presentation. And in regards to other webinars, we will be posting a lot more over the next week or so, so please look out for those. And this gives you a brief overview of our upcoming courses. Most of our higher education courses, our degrees have passed for the year, so all the application deadlines have passed now. So you're looking at mainly January and February if you're looking at studying one of our bachelor's courses or graduate certificates, master's degrees. And then we also have our professional certificate courses, our short courses, and our advanced diplomas. Those are starting throughout the year. So every course, every short course and advanced diploma is different. They all have different intakes and different frequencies, so it's best to check the schedule page for those ones. Schedule page is that link at the bottom of the screen. You can see all of our upcoming courses and intakes. And as mentioned at the start of the webinar, we do provide a free certificate of attendance for these sessions. And the QR code there on the screen, you can scan that with your phone's camera if you've got that there, or you can click the link. I'll just put the link in the chat box for you. So if anyone would like to receive a certificate of attendance, you must fill out the form that is linked to the to that link or QR code, and I will send that out to you likely later today. So yeah, just you can save that link for later. You can have it open in another tab. You don't have to do it immediately, but if you would like a certificate, please fill that out and submit it, and then you'll be sent a certificate via email. Just leave that out for a few more seconds. Okay, now I'll skip over this slide. We'll still do a Q&A, but I just like to leave it on this slide because if anyone needs to go, thank you very much for attending today's webinar. We really appreciate it, and all of our contact details are up on the screen there if you need them. And we will take any questions now. Quasar, yes. Do you update units of Master of Engineering degrees every year? I'm not sure if it's that frequently, but I could be wrong, Quasar. I'm not entirely sure on that question. That would be a better question for possibly one of our course advisors, or if you'd like to send me an email, I can follow that up for you. There's a couple of technical questions coming through there, Ali. I wasn't sure if you might want to answer a couple of those. There's one from Malebo and Eureka.
Yeah, yeah, definitely. Thank you, Riley. Yeah, actually, one of the main important impact of Industry 4 is on the energy efficiency, because when you have decentralized and smart equipment, one of the point of being smart and being a decision maker is when we have to consume more energy, when we have to consume less energy, for example, during the low production time. So definitely lots of the machines turn themselves like off or going to standby or something like that. So they understand that when is the time for fully production, or when is the time for taking rest and saving energy, something like that. This is some kind of examples of that. So decentralization is one of the main like aspect of using less energy, or it's better if we say that consume energy in an effective way. So I think I hope this is the answer of your question.
Thanks, Ali. If anyone has any other questions, please feel free to put them in the chat box. We'll stick around for another couple of minutes. But yeah, we hope you enjoyed the session. So I'll put the link to the form for a certificate of attendance in the chat box again. And for the slides and the video recording of today's today's webinar that will be sent later today via email to everyone that's registered. There's a couple more questions come through there.
Yeah, so first I answer Andrew's. Definitely, what do we have? So, for example, we have temperature, we have pressure, we have flow of the fluid. All of them are analog signals. So we capture them as analog. That's why we have to use 4 milliamps to 20 milliamps. And then this is another, there are some other bases whereby this is the main, because all signals around us are analog signals, like pressure, temperature, fluid, and so on. And then Malibu asks if MEMS. Yes, MEMS is smart sensors. That's great. This is the a principle of smart sensors. That's so. Did I answer your question? If yes, I'm going to Eureka. It says, what are the limitations of such industry for smart factories? So actually, the limitation pops up when we start transferring all the traditional factories to smart factories. We can't say there is limitation or not. We are reviewing systems. So based on studies and researchers, and based on the available examples that we have already, which I showed you, for example, GE or Airbus, which also have some small factories, there shouldn't be any special limitation for that. But we have to do and we have to see. So they are all comes after practicing. We are not sure. PLCs are very smart, so they are very smart brains, so they can be programmed. Maybe in the future we are going through another devices which are more intelligent, but so far they are working very good, and they are very compatible with Industry 4. They are main part of Industry 4 as well. We're not taking very serious mess in building smart such as power. Not from systems, so starting with IT and OT understanding smart devices. Technical web affecting Industry 4 revolution. So, yeah, this is another good question by Fernando. So, it needs lots of researchers. We are in the first step, I believe that we are in the first step. We have to implement them. We have to see the bugs. And we have to set up some special foundation like standards. And then we can see what is the impact. Because when Industry 3 has been developed, many people thought that, oh, this is the end of the world. So we have robots, we have IT, so we have everything. And before that, when mass production has been improved, has been developed, so they thought that, all right, mass production is everything. But after a while, we faced with lots of problems. So to solve these problems, we are moving to Industry 4. And maybe to solve the problem of Industry 4, we have to move forward to Industry 5 and so on. So no one knows. It needs lots of researchers in this area.
Great, thanks, Ali. I believe we've run out of time, but thank you again, everyone, for attending, and please feel free to contact us at any time if you have any queries about our webinars or our courses. We would love to get in contact, and thank you very much again, Ali, for presenting today. We really appreciate it.
Thank you so much, Riley, and thank you everyone for being patient for this presentation. Thank you.